idea what Hadoop is all about. So let's start the class with the agenda. So the agenda for this class will be what is Hadoop, why do we need Hadoop, how Hadoop works, AFS architecture, what is MapReduce, Hadoop clusters, Hadoop processes, topology of a Hadoop cluster, distinction of Hadoop framework, and last but not the least is prerequisites to learn Hadoop. So you may be seeing so many new words like HDFS, MapReduce, cluster, but don't worry about these new things. We'll be covering these things in more detail in the coming slides. So let's start with the first one. That is, what is Hadoop? So Hadoop is an open source framework. You may be knowing that open source framework means that is free of cost available over internet. Apache team has developed the Hadoop, and this is very emerging technology and hottest topic in the market nowadays. But still, this is not a paid service. You can go to Apache website and you can download it for your own purpose or for your enterprise purpose. So Hadoop is used for distributed processing of large data sets. It seems like there are so many technical words in this slide, like distributed processing, large data sets. So before we directly dive into the technical stuff, let's start our demo with some layman example. Because first of all, we must be clear with the concept of Hadoop. After that, technically, we can discuss anything, we can dive anything. So let's take an example. Suppose we have a school, and in that school there is a principal, and there are 10 teachers as well along with the principal. Now there is a task. The task is checking of 1,000 answer sheets of students. Now the principal has two options. Either principal can start checking the 1,000 answer sheet by himself. He may be qualified enough to do this task, but the thing is, if a single person will try to check 1,000 answer sheets, he will be taking a lot of time. Instead of that, if the principal can distribute the task among his 10 teachers, the same task can be completed in less amount of time. Because very simple mathematical concept, more number of workers, they will take less time to complete the job. So the same process, same concept applies to Hadoop. Instead of doing a big and complex processing on a single machine, that might be taking more time. Instead of that, if we can distribute the processing among multiple machines, our processing can be completed in less amount of time. So this was the example for make you understand the concept of Hadoop. So we have one more similarity. Yeah. Do we have any doubt? Okay, so I was explaining about one more similarity between the school example and Hadoop. In school, principal was the controller. We can say he was the organizer who was distributing the task among his 10 teachers. Similarly, in Hadoop, we have multiple machines, out of which one machine is working as master machine. You can say controller machine, and remaining all the machines are working as slave machines. So, just like principal was not checking any answer sheet, he was simply distributing the task. Similarly, your master machine does not participate in the process, but it can distribute the task among all the slave machines so that the task can be completed in less amount. So this is all about the third line. Now I will cover the third line again. Now you can understand it. So Hadoop is used for distributed processing of large data. As the data is very large, very complex, so processing of that data we are not doing on a single machine. Instead, we are distributing it among multiple machines. So this is about third line. The next we have is it works across clusters of computers. Cluster of computers means a set of multiple machines which are connected to each other through some network. Because your master machine has to communicate with the slave machine, because it will be distributing the task among the slave machine. It has to communicate with the slave. So Hadoop is a set of multiple computers, multiple machines, and using a simple programming model map. You know that we are not processing anything on a single machine, but we are distributing the processing. It means that we need something which can be executed parallelly on multiple machines, and that is nothing but MapReduce. So MapReduce is a programming model which will help you to process your data parallelly, distributively on multiple machines. So this is a brief about what is Hadoop. In the coming slides, we'll be exploring these features in more detail. So we are proceeding now to the next slide. The next we have is why do we need Hadoop? Whenever we are planning to learn a new technology, first of all we should know why do we need that. After that only we should proceed to learn or to use that technology. So the first and the most important reason is data is growing fast. Why the data is growing faster? Because you know that nowadays everyone is engaged in internet. You are using your internet for net banking. The banks are using internet for transactions. You are a part of Facebook, Twitter, LinkedIn. You are purchasing the products from online websites and so many things. Whatever activities we are performing over internet, that is nothing but ultimately increasing the data. And the data is in too much size that we can't handle on a single machine. So in old days, we were dealing with the data in MB or G. But in present scenario, as well as in the coming days, we have to deal with terabytes and petabytes of data. So that was I was talking about the online sources of data. Let's talk about offline sources as well. You must be going to Walmart or Big Bazaar to purchase the household items. Once you are going to Walmart, you are purchasing some products from there and they are capturing your details. Details means your customer ID, your customer name, product ID, product name, product price, and last is you can say the mode of payment, whether you have used your debit card or credit card or cash. So if there are thousands of customers are coming to Walmart to one store, and there are thousands of Walmart stores across the globe, so at the end of the day, there will be millions of records captured. And if I will say, I want to analyze the purchase history of Walmart of last 5 years, you can't even imagine the amount, the volume of it. So when we have to process that amount of data, single machine will not work. We need the concept of Hadoop so that the large amount of data, the big data can be analyzed. And the analysis is for business intelligence, because the Walmart may be interested to find out what percentage of the customers are using the credit card or Standard Chartered Bank. Accordingly, they might be giving some offer, they might be doing some tie-up with Standard Chartered Bank or anything. Similarly, they may be interested to find out what percentage of customers are purchasing the products on which we have offered more than 20% discount. Because depending upon the responses, it might be increasing or decreasing the discount. So it's all about business intelligence. It's all about increasing the business. So from everywhere, whether it's ATM, whether it's online stores, whether it is offline grocery stores. Every company is capturing the data. Every company is maintaining the history so that they can analyze their history data and accordingly they can enhance their data. So this was the most important reason for using Hadoop. The next we have is the performance of traditional application is decreasing. Traditional application means we are software like Oracle or Teradata or anything on a single. So if you are doing everything on a single machine, definitely there will be decrease in performance. Suppose now you are having 200 GB of data and you are dealing with that data with the help of single machine. It's fine, not an issue. After 5 years, when your business will grow up and your data will increase from 200 GB to 20 terabytes or 30 petabytes. Even in that amount of data, you are using your single machine, the same hardware. Definitely there will be decrease in performance. So you will increase the load, there will be decrease in performance. But if you will ask me, does it rule applies to Hadoop? I will say no. This rule does not apply to Hadoop because the number of machines in Hadoop is not constant. Depending upon your choice, depending upon your budget, you can decide how many machines you want to use. Like again coming to the same example, initially when you are dealing with 200 GB of data, we can use a Hadoop cluster of 2 machines or you can say 5 machines. And when you are dealing with 20 terabytes of data or you can say 30 petabytes of data, we can increase the number of machines. You can say we can set up a Hadoop cluster of 30 machines or 50 machines or any number of machines. There is no limit on number of machines in a cluster. Depending upon your requirements, depending upon your budget, we can use any number of machines in Hadoop. So this was another reason behind using Hadoop. The next we have is failure is expected rather than exceptional. So when we are working on any software or any hardware, we cannot guarantee that the system will not fail. It may fail due to power failure, due to any virus attack, due to any software bug, anything. But if you are doing everything on a single machine, and if that is crashed, that's a very bad thing. Because whatever processing you have already done, you have to do it again. For the same scenario, if I will compare with Hadoop, in Hadoop we are having multiple machines. So if 2 machines or 3 machines are down out of 10 machines, that does not create an issue. Comparing with the school example, if 2 teachers or 3 teachers are not feeling well, does it mean that your task of checking 1,000 answer sheet will not be completed? No, it's not like that. Your task can be still completed with the help of remaining available features. The only thing is they might take little more time because previously the job which was supposed to be completed by 10 machines, now that job will be completed by, you can say, 7 or 8 machines. So they may take little more time, but they will be definitely completing the job. So this is all about why do we need Hadoop. Before we proceed to the next slide, if you are having any doubt, we can take those doubts, then we'll proceed to the next slide. So Sri and Subra, are you having any doubt or shall we proceed?
No, I do not have any doubt. I'm good.
Okay, thank you, Subra. Okay, so in that case, we are proceeding now. The next we have is how Hadoop works. Now we know that what Hadoop is and why do we need that. But how it's working. So Hadoop core consists of 2 modules. We were talking about the processing part, that the processing was quite difficult and quite complex and quite big. That's why we distributed the processing among multiple machines. The same problem may arise for storage. Suppose we have a big file which could not be stored on a single machine. So just like we distributed the processing among multiple machines, similarly we can distribute the storage as well among multiple. So the first part of Hadoop, which is dealing with the storage part, is known as Hadoop Distributed File System. In short, you can simply call it as HDFS, Hadoop Distributed File System. And the second part of Hadoop, which is dealing with the processing part, is known as MapReduce. That is again consists of two words, map and reduce, or you can say mapper and reduce. So this is very brief about the two parts of your Hadoop. So we'll be exploring these things in more detail. We'll be starting with the first one, that is Hadoop Distributed File System, that is HDFS architecture. So let's have a look at this diagram. Till now we were using the term like master machine and slave. But technically in Hadoop terminology, the name of master machine is name node, this one, and the name of slave machine is data. So in this diagram, we have one name node, we have one backup node as. Just like in school we have vice principal, so that in case the principal is absent, there must be someone to take care of that. So we have one name node, we have one backup node, and apart from these two machines, we have 5 data nodes, which are actually my 5 slave machines. So these dotted arrows indicate that name node is controlling all the slave machines. So you can say name node is controlling all the data. So this was all about the architecture of Hadoop Distributed File System, that is HDFS. Coming to these colorful blocks. These colorful blocks you can count 3, 5, 5, 15. 15 colorful blocks are actually part of a big file. The big file which could not be stored on a single machine. What your Hadoop did is Hadoop has splitted that big file into smaller parts. And the smaller parts now can be distributed among multiple machines. You can see that 3 blocks have been stored on first data node. 3 blocks have been stored on the second slave machine. Similarly, every machine is participating into the storage. So now we are having a distributed environment which can store any amount of data. So now every slave machine is having its own hard disk, its own storage media. And one more thing you can notice is name node and backup node does not have its own hard disk. It does not mean that they don't have hard disk. They have hard disk, but they are not participating in the storage of data. That's the main thing, because name node and backup node, they are for controlling the things, for coordinating the things, for managing the things, for distributing the storage and processing and all. Your master machine does not participate in the storage and it does not participate in the processing. That's why your complete data has been separated and it has been stored among multiple machines. So this is all about the first part of Hadoop. We are proceeding to the next one now. The next is, what is MapReduce? So first of all, you know that MapReduce is a programming module which can help us to write such programs which can be executed on multiple machines parallelly. Hence, we can rapidly process large amount of data. And this is playing very important role in Hadoop framework. So why it's playing important role? Because it is, you can say, storage is not a big deal. We have stored large amount of data, but storage we can accommodate, like we can use extra hard disk, we can use portable hard disk, we can use some centralized location. But as far as processing is concerned, processing of terabytes, petabytes of data is not a simple thing. That's why the processing part of your Hadoop, that is MapReduce, is playing a key role in Hadoop sale. The next we have is the definition of mapper and reducer. So before we explore mapper and reducer, let me go back to the school example, which will clarify your doubt, which will make your concept more clear. So in the school, principal distributed the task of 1,000 answer sheets among 10 teachers. It means that one teacher is responsible for checking only 100 answers, and he will be preparing the result for those 100 students. Now the second teacher will be doing the same. He will also be preparing the next 100 students. Similarly, every teacher will be ready with 100 students result at the end. Now, principal will say that I have distributed the task among all of you. That's a different thing. But it does not mean that I want 10 different people. I still need one consolidated. So he may give instruction to one teacher that you please collect intermediate results, or you can say you please collect the small results from each teacher, consolidate this into a single unit, and that is all what I need. So the first activity, checking of 100 answer sheets by each teacher, that processing is known as method. And the second activity, one teacher is collecting the smaller results from each teacher and creating the final output. That activity is known as this. So this was in the context of full example. Coming back to Hadoop, mapper is a function that process input data from HDFS and generate intermediate output data. Why we are calling intermediate? Because this is not the final output. This needs to be consolidated. So individual machine is doing its own part. Whatever is assigned by your master machine, individual part they are doing, that is known as mapper. And after that, one machine will be selected by a master machine that you have to consolidate. So that machine will be contacting every slave machine, collecting intermediate results, smaller results from each machine, consolidating that into a single unit, and that activity is known as a reducer. You can have a look. Reducer merges all intermediate data from all the mappers and generate final output. So any MapReduce job, any Hadoop job consists of mapper and reducer tools. Mapper is running on every machine distributively, and reducer will be running on a single machine for consolidation. So this was all about two parts of Hadoop, that is HDFS and map. So in case you are having any doubt, we can take those doubts. Otherwise, we'll be proceeding to the next.
I'm good.
So we have the next one. The next we have is a Hadoop cluster contains of multiple machines. As we explored previously, that there is no limit. You can use any number of machines in your Hadoop cluster. Let me tell you that Yahoo has set up a Hadoop cluster of 2,000 machines. And what they are doing is, they are actually analyzing Yahoo page to detect the spam. So, as per the requirement, we can have any number of machines. But as far as the type of machine is concerned, we are having only three types of machine in our Hadoop cluster. First is name node, that is my master machine. Second is secondary name node, that is the backup of my master machine. And all remaining machines are slave machines, which are known as data node. So these are three types of machines. The next we have is Hadoop processing, or you can say Hadoop service. So below are the services which run on a Hadoop cluster. So let me tell you that I will be spending initial 2-3 classes on Hadoop installation, so that Hadoop can be installed on your system. Because I have already installed Hadoop on my system. If I will show everything practically through the screen sharing to all of you, I think that would be more practical for me and less practical for you. Will gain the confidence, you will understand the concept when you will do practical along with me on your system. So we'll be dedicating 2-3 classes initial for installation of Hadoop. Anyways, when your Hadoop will be installed on your system, there will be few services running. Let's check it out. The first service is name. You may be thinking that previously I was telling that the name of the master machine is name node, and now I am saying that name node is a service. So name node is a service only, but as it is running on master machine, that's why your master machine is also known as. Anyways, name node is a service, is a process which runs on master machine and it is handling storage part of your Hadoop. Second process we have is job tracker, which also runs on master machine and it takes care of MapReduce part, MapReduce, the processing part of your Hadoop. The next we have is the data node, which runs on slave machine and it is taking care of storage part. It seems like data node and name node both are correlated. Yes, absolutely right. Both are working for your HDFS part, your storage part, with the only difference that name node is running on master machine and data node is running on slave. Similarly, we have the next process, that is task tracker. It is running on slave machine and it's responsible for handling the MapReduce part. You can say that job tracker and task tracker both are working for MapReduce part, with the only difference that job tracker is running on master machine and task tracker is running on slave machine. So this is all about different services which are running on master machine and slave machine in your Hadoop cluster. I have drawn a diagram just for your better understanding. The middle diagram is my master machine, middle block on which name node process and job tracker process is running. Both the master process are running on your master machine, which are taking care of storage and MapReduce part of it. We have a secondary name node as well, so that in case the main machine is down, main master is down, secondary machine can help you to take care of that. Remaining all the machines are slave machines, and you can see that on every slave machine, data node and task tracker, these two processes are. So ultimately you can say that name node process is controlling all the data node process on slave machine, and job tracker process is controlling all the task tracker processes on every slave. So this is all about the network topology and different services of Hadoop cluster. So we can proceed now to the next one. The next we have is distinction. As we are moving from one technology to another technology, we should know why Hadoop is distinct from other frameworks, why it's different from other frameworks. So the first reason is simple. Simplicity. As far as software is concerned, you know that is quite simple. You don't need to pay anything. You don't need to purchase any license. Simply go to Apache website, download Hadoop. From there, use it for your own purpose or for your enterprise purpose. As far as the hardware is concerned, you don't need to purchase any special server or any special hardware on the market. So, the next is Hadoop allows users to quickly write efficient parallel code. It allows you to write such programs which can be executed on multiple machines at the same time. The next is reliability. As Hadoop runs on commodity hardware. Commodity hardware means any simple PC or any laptop, whatever you are using, at your home, that can be used as a Hadoop. So as we are not using any special server or any special hardware from the market, it means that there are chances that sometime our system may fail. But nothing to worry, your Hadoop master machine will take care of that. Let's take an example. First of all, I would like to tell you that as a user, we never interact with slaves. We always interact with master machine, and then master machine is interacting with all the slaves. So suppose initially there were 10 machines in your Hadoop cluster, and you submitted some job to the master machine. So your master machine might have distributed the task among all the slave machines. So initially, all the 10 machines were running fine. But before completion, immediately, suddenly, 3 machines crashed. Now what will happen? First of all, as a user, you don't have to worry. Your master machine will automatically have been crashed. It means that whatever part of the job which was scheduled on those 3 machines, that part of your Hadoop job need to be scheduled again on any other available machine. So scheduling of job, rescheduling of job, finding out which machine is live, which machine is dead, all these activities are automatically internally performed by your master. So this is all about reliability. The next is scalability. You know that we can increase or decrease the number of machines in Hadoop cluster anytime. If you are saying that our job is getting time and we want to decrease that, it simply means that you need to add more machines to your existing Hadoop cluster. Or if you are saying that my jobs are getting completed in pretty less amount of time and I think I don't need 10 machines. Okay, not an issue. We can remove few machines from your cluster. So that is quite flexible. That is completely scalable. As per the requirement, we can adjust the size of our Hadoop cluster. So this is all about distinction of Hadoop framework from other frameworks. So we are almost done with the technical introduction of Hadoop. But we are still left with last but not the least slide, that is free. So if you want to go for this training, there are something which we need. The first and the most important requirement is Linux based operating system. I am sure that most of you you can say you have joined today's demo from Windows, because Windows is the most popular, you can say, operating system. But let me tell you, unfortunately, Windows will not help you in learning Ubuntu, because Ubuntu can't be installed on Windows. We need any Linux-based operating system to learn Hadoop, for doing the practical Hadoop, and to install. The possibilities are Mac operating system, Mac OS, that is Apple machine. We may have Red Hat or Ubuntu. Why I have highlighted Ubuntu in a different color? Because in case you don't have any of these operating systems, Ubuntu will help you. First of all, this is open source, which can be downloaded and installed. Second thing is, we can install Ubuntu in a virtual machine. It means that we don't need to delete your Windows. Your Windows will be intact. On the top of Windows, we will be creating a virtual machine, and inside that virtual machine, we will be installing our Ubuntu. You can say that Windows will be there for doing your personal stuff, and Ubuntu will also be there for doing the Hadoop related. So first requirement is the most important, and that is not a big deal. We can achieve that within 15-20 minutes. That is one-time activity. The next requirement is Java 1.6 or higher version required. That is not an issue. That is again open source. Download it, install it, within 5 minutes we can do that. This space is required for your storage part, you know that, for HDFS part, and RAM is required for your MapReduce, you can say, for your processing. But we know that if someone is having PC or laptop, definitely he or she will be having hard disk and RAM. So that is again not an issue. The next requirement is a cluster of computers is required. As per this diagram, you may be thinking that we need 7 machines to learn from. One is master machine, one is backup master machine, and remaining 5. But no, that is not required. For learning Hadoop is sufficient. On a single machine, you can install Hadoop.
Hey, anybody else on the call?
Hello?
Yeah, hi. What happened?
I think we lost Neeraj.
Okay, hold on 1 second. Let me see what happened. Give me a minute.
Sure.
Swati, can you hear me? Hi Swati, can you hear me?
One.
Hey Swati, can you hear me?
Yeah, Neeraj?
Yeah, Swati, I don't know why my WebEx client crashed suddenly, but anyways, we were almost done. So
Okay.
shall we? I think yeah. So we were on the last slide actually.
I'll
So
make you
please
the present.
make me yeah. Okay.
Sure, I'm doing it.
So we were on the last slide. That was a prerequisite. So we don't need cluster of computers. A single machine is sufficient for learning Hadoop. Logically, it is possible to make a single machine as master as well as slave. We can say that uh, all the master process will be running on your machine as well as all the slave process will be running on yours. So with this slide, we are done with the introduction of Hadoop. So in case you are having any doubt, technical, non-technical, anything, you are moved on.
Hi, Neeraj. This is Shubhra. I have a question.
Yes, Subra, please go ahead.
Can I have an iMac, but I never worked with Java on an iMac. I used my Windows, but you said that we're gonna use Linux, and I can pretty well use the Linux on my iMac. But can I use Java